Hi, welcome back. This is video 4J, the last videos in the Lesson 4 series. Today we're going to learn about z-scores. And so the main idea here is that we want to determine how unusual a data value is. And this is usually done with respect to the mean, how far off is the point from the mean, and in terms of the standard deviation. So this is done with respect to the mean. And in terms of the standard deviation. Marker. And so next we'll look at the formula for z-scores. We'll incorporate that. Sorry, forgot my place here. Before we get to the formula, let's motivate this with an example. So you're in Dr. Levy's English 101 class, and your final grade was an 88. You're also in Dr. Vinton's Biology 208 course, and your final grade was an 81. You have a friend that's taking the same classes. He got an 80 in English and a 90 in biology, and he's claiming, hey, I did better than you during the semester because biology is a harder course. And if you add up my two grades, they add up to a higher sum than yours. So we want to know if we can sort of put him back in his place by standardizing the grades. You all know that it's difficult to compare a 90 in one course with a 90 in a different course because different courses have different sort of standards to them, levels of difficulty. So let's compute z-scores to help us with this. So first off, just the definition of a z-score. A z-score tells you how many standard deviations a data value is away from the mean. So a z-score is the number of standard deviations a data value is from the mean. It will also tell us if your data value is above the mean or below the mean. We'll see that when we compute this. So the formula for a z-score we get by seeing how far the data point is from the mean. So we take that data value, we subtract off the mean. That'll tell us how far the data point is from the mean. And you can see there that if your data value is above the mean, this difference is going to be positive. If your data value is below the mean, that difference will be negative. And then we want to see how far it is from the mean in terms of the standard deviation. So we'll divide this by the standard deviation. When you have sample data, if we write this with symbols, the data value will use the symbol y. For the mean, we'll use y bar. And the sample standard deviation will use S. So next we'll compute some z-scores, applying that formula. Okay, so back to the example with you and your friend. We've got a summary of your scores and his scores and the course averages. So in English, you had an 88, he had an 80. The class average in English in that course was a 75.5, and the class standard deviation was a 5.5. Whereas in biology, your grade was an 81, his was a 90. The class average in biology was only a 61, and the standard deviation was 13.2. You'll notice that the standard deviation was larger in biology, so there was a wider range, wider spread of course grades in that course as compared to the English course. So next, let's look. We know how your scores compared, but let's standardize those scores by computing the z-score and see how you each did relative to the class averages. So I'm going to move over to the sideboard here. Bring my numbers with me. So let's compute the z-score for you and your friend in English. So the z-score formula, again, we're going to see how far your grade was from the course average. So in English, you had an 88. The course average was a 75.5. And the standard deviation was 5.1. Make sure that you take that whole difference, divide by 5.1. And so in English, your z-score is 2.45. We know that you scored better than the class average, and in fact, you scored 2.45 standard deviations above the course average in English. Okay, how about your friend? Your friend had an 80 in English. Again, the course average was a 75.5, and the standard deviation was 5.1. Your friend also scored above the course average, and so his z-score is going to be positive as well. His z-score was a 0.88. So he didn't quite score one standard deviation above the average. You can see if you started at the average and added one standard deviation, we'd be at an 80.6. He wasn't quite at 80.6, so he was just slightly under one standard deviation above the mean, 0.88 standard deviations above the mean. Okay, let's go to the biology course now. In the biology course, your score was an 81. In biology, the class average was a 61. And in biology, the standard deviation was 13.2. And so your z-score in biology was a 1.52. Your course average was 1.52 standard deviations above the average for the class. Okay, how about your friend? Your friend's score was a 90. And again, the course average was 60. The standard deviation was 13.2. So your friend's definitely going to have a higher z-score here. Your friend has a z-score of 2.2. So his grade was 2.2 standard deviations above the mean. Okay, so if you want to make the argument, that you did a little bit better, you could do a couple things. Perhaps you could take the sum of your z-scores and you were more standard deviations above than your friend was. You could maybe get the average of your z-scores, and I think you did better than your friend. So rather than looking at the actual grades, if you compare z-scores, an argument can be made that you scored better than your friend in your two classes overall. Okay, back to the board. Wrong way. There we go. Okay, so we saw different z-scores. Let's talk about some z-scores that are common, some z-scores that you won't see as often. If you have observations that are within 2 standard deviations of the mean, either 2 standard deviations above the mean or 2 standard deviations below the mean, if you're within that range, those observations are not considered unusual. So any observations that are plus or minus 2 standard deviations from the mean are not unusual. Once you have observations that get to be 2 to 3 standard deviations from the mean, they're starting to be unusual here. So between 2 to 3, and in either direction, plus or minus just means I could be 2 or 3 above the average or 2 or 3 below the average. Those observations are unusual. Okay, if you go more than 3 standard deviations away from the mean, that's not going to happen very often. So you won't get z-scores much larger than 3 or smaller than -3 very often. Those are rare. Eventually in this course, z-scores are important. We'll start computing probabilities and we can figure out the likelihood of getting those kinds of z-scores, and you'll see that they'll be very small. And then some other things that we've mentioned. A z-score that's positive, that simply indicates that the data value is above the mean. And we didn't have any over here, but if you had a z-score that was negative, that would indicate that your data value was below the mean. So the sign of the z-score simply allows you to know if your observation was above or below the mean. When we convert a data value to a z-score, we call that standardizing. It can be really hard to sort of compare grades when you know that different courses have different averages, so this sort of evens things out. It standardizes them. It looks at everything in terms of how many standard deviations you are away from the mean. And if you're asked if a data value is an outlier, then we would use the upper and lower fences like you learned in a previous lesson. If you were asked if a data value is unusual or rare, you could convert that to a z-score, and that would allow you to make that determination. Again, if you have z-scores that are beyond 3 standard deviations from the mean, they're very rare. If you're getting to be between 2 and 3 standard deviations away from the mean, those are unusual. All right, let's look at another example. All right, Kiplinger ranks colleges each year, and we have data for 100 best values in public colleges. The variable of interest is debt at graduation. The data were reasonably symmetric, so means and standard deviations are appropriate since the data were fairly symmetric. And we have some summary statistics here. We see that the average debt at graduation was $20,038. And we're going to compute some z-scores. So students at JMU, at James Madison University, should expect $18,183 in debt upon graduating. And we would like to know what the z-score is from that, and then we can figure out is that an unusual amount of debt. So we'd like to compute the z-score for James Madison. So here's our formula. The observation we want to get the z-score for is James Madison's debt at graduation, which is $18,183. First thing we'll see is how far that is off from the mean. The average for these schools was $20,038. You'll notice that this time the average debt is less than the mean, so this is going to have a negative z-score. And in this case, having a negative z-score is probably a good thing, especially if you're a parent paying for the school. And then we'll divide by the standard deviation. So the standard deviation was 4,157. And again, just make sure you take that entire difference divided by the standard deviation. And we'll end up here with a negative 0.446. So JMU is not quite a half a standard deviation below the average debt at graduation for all the schools that were in this data set. Is this unusual? Not unusual at all. We're not even a half a standard deviation below the mean. When you're within 2 standard deviations of the mean, those values are not unusual. So this would not be unusual. Only 0.446 standard deviations below the mean. Okay, part B. Give a range of debt that would not be unusual. We found out that JMU wasn't unusual at 18,000. What's a range of values that would not be considered unusual? So we said that data points are not that unusual if they're within 2 standard deviations of the mean. So let's figure out what the debt at graduation would be if we were 2 standard deviations below the mean, and if we were 2 standard deviations above the mean, and then if we're within that range, those values would not be unusual. So it's not unusual to be 2 standard deviations away from the mean there. So let's find out what the debt at graduation is if we start at the mean and go down 2 standard deviations. I'll make that an S. So if I start at $20,038, and I subtract off 2 standard deviations, I end up at $11,724. So this would be a debt at graduation amount that falls 2 standard deviations below the mean. If we go 2 standard deviations above the mean, I'm just going to add 2. We end up at a debt at graduation of $28,352. So a range of debt values that would not be considered unusual would be any debt at graduation values between $11,724 and $28,352. All right, one more. Okay, this one's a little bit different. This time you're given the Z-score for a university, but not their debt level, and so we would like to find out what the debt is. So a certain university had a Z-score of negative 1.63. Compute the debt at graduation. So let's start with our Z-score formula. And this time we know the Z-score. We know the average debt, we know the standard deviation. What we don't know is what the actual debt was. What was the data observation that corresponds to that Z-score? So we'll fill in what we know and solve for what we don't know. So we don't know the observation that corresponds to. The average is still $20,038. And the standard deviation was still $4,157. And when I look at this, in the context of this problem, this is probably a good thing that this Z-score is negative, because I know that wherever this school is, the average or the actual debt here has to be below the mean. Okay, so now it's just a matter of using some algebra. I'll multiply both sides by the 4,157. And then I'll add the $20,038 to both sides, and we'll have our average or our debt for this particular school. And so if you do that, we will find out this corresponds to a school with a debt at graduation of $13,262.09. I was kind of curious because my kids are approaching that college age. How unusual would it be to have, where you go to a school where the average debt at graduation was 0? So you might try that. Plug in a 0 here and compute that Z-score and figure out if that was a rare event, not so rare, and you can see whether I was happy that I did that or whether I thought, oh boy, better start saving some more money. So that's it for Z-scores.